Okay, welcome to today's lesson on solving inequalities. Just to get you started, I'm going to let you know I'm going to move a little fast through this video. If at any time you need to pause or rewind just to go over something, feel free to do so. What is an inequality? Well, when you think about the actual word inequality, like the English definition, it means not equal to. So when we think about all numbers in general, let's say just if we call two numbers A and B, two numbers A and B, I can pick any numbers I want to for these two numbers. There's a special property called the trichotomy property, where it says if two numbers A and B, if there are two numbers A and B, then they have to follow three rules. One of them is that A equals B, and that's if A and B are the same number. And then we have A has to be less than B, or A has to be greater than B. So if A and B are real numbers, and which is any number we can choose, A and B have to fall into one of these. So we've dealt with equations. Now we're dealing with inequalities, where A is less than B or A is greater than B. Now we're going to be talking about this relationship throughout. And how do we solve inequalities? That's the next question. Well, we solve inequalities just like we're going to solve equations. You're going to try and isolate the variable, get the variable on one side, get all the numbers on the other side, and follow the golden rule of algebra. Whatever you do to one side, you have to do to the other. Keep that balanced. Otherwise, it's not a true statement. So let's look at some examples. These are just basic inequalities, 1 and 2 step inequalities, just so you can see that they're solved just like regular equations. So first I'm going to go through here, and you got x plus 5 is less than 3. I'm going to do exactly like I would do with a normal equation. I'm just going to subtract 5 from both sides. And that gives me x is less than negative 2. And that's it. That's my final answer. That means the only way this is satisfied is if x is less than negative 2. That's the only way this equation works. And we can graph these. So when I graph this inequality, I'm just going to make a number line. It doesn't have to be a real specific number line. The only point I really care about is the point negative 2. And I'm looking at what happens around negative 2 and what happens before, what happens after negative 2. So I know that all my solutions to this equation are less than negative 2. So I'm going to put a circle right here, and I'm going to say all my solutions are that way. And I'm just going to kind of fill this in, just so you can see that all my solutions are there, and it goes on to infinity. So I have from negative 2 to negative infinity. So this open circle, that's what I put whenever I don't have an equal to. If it's just less than, then it's an open circle. If it's greater than or equal to, or less than or equal to, basically if it's equal to also, I fill in that circle because I'm including the point negative 2. So this next problem has a greater than or equal sign, so let's see how it's solved. Again, solving just like an equation, I'm going to add 11 to both sides, trying to isolate the variable. So I get 4x, not equal to. 4x is greater than or equal to 20. So now I'm going to divide both sides by 4. And I get x is greater than or equal to 5. So any number that is greater than or equal to 5, so any number 5 and on, satisfies this equation. It means I can plug it in up here, and it's going to work. Whatever number I plug in is going to be greater than 11, or greater than or equal to 9. So I can also draw this on a number line. Alright, and all I care about is the point 5. I'm going to throw that right there in the middle. And I know this time that I'm including the number 5. So I'm going to fill in the circle and then say my solution set goes this way. So all numbers greater than or equal to 5 satisfy this equation. Alright, so the problem number 3 is a little bit different. Here we actually have a negative on our variable. So this is going to change things up a little bit. So this is where you have to be really careful when you're solving inequalities. This is the only thing that's different when it comes to solving inequalities and solving equations. So I'm still going to kind of work it out, get the variable by itself, but along the way there's one little rule you have to watch out for. So I've got this 13, so I'm going to subtract 13 from both sides. That gives me negative 2x is less than or equal to, and I subtracted 13, so I'm left with negative 2. Now your next step is to divide by negative 2, but you have to be careful, because whenever you divide or multiply by a negative number, you have to flip the inequality sign. You switch it. So if it's less than, it comes greater than. whatever. If it's greater than, it becomes less than. You have to flip it back and forth. So this negative 2 cancel to 1, so it gives me x. But I have to flip this sign. So it's no longer less than or equal to, it becomes greater than or equal to. And negative 2 divided by negative 2 is just 1. So that's actually my solution. And the reason this happens is because instead of dividing by negative, I could actually add 2x to both sides here. And I'm going to work up. It's going to look a little weird. But I'm also going to subtract 11 just to kind of, get the variable by itself in one step. So my 2x is over here now. I added 2x to both sides. I still have the same sign. And I subtracted 11, so I have 2. So again, just to kind of go a little bit further, I would then divide both sides by 2 and get x is greater than or equal to 1, just like that. But I read it backwards. So if you look, whichever way, that happens more often than you think. That was my son holding a bowling ball, by the way. If you read this, this is actually the same thing. This right here and this right here are exactly the same thing. It's just in math, we like to keep it uniform and keep our variables on the left side and read from left to right like we do English. So this is actually the same thing as x greater than or equal to 1 if I read it backwards, or x greater than or equal to 1. So to kind of make the process quicker and as a shortcut, we just say flip the sign. Alright, now there are special types of inequalities here. There are compound inequalities and absolute value, and we're going to go over those next. So compound inequalities are just when you have two inequalities joined by the words and, or. So you got and or. Those are compound inequalities. And how do we solve these? Well, we solve these exactly like we solved the other ones. There is no difference. The only thing is you have to be real careful. You're going to be doing multiple operations because an and inequality can be written as a compound inequality and one big long inequality. So I can actually, because these numbers are, this is negative 6 is less than x if I read it backwards again, and then x is less than 2, I can actually write that inequality like that. I can make it one inequality. And I can do the same thing here. This is negative 1 is less than x plus 2, which is less than 4. So anytime that your variable is in between the two numbers, you can write it as a compound inequality. Now the ors you can't change. It's just what it is. You can't switch those around. You can't make that a compound inequality because the x isn't in between that. Your solutions aren't in between there. So let's see how to solve these inequalities here. So I've rewritten them already. Oh, that's not supposed to be on there. I don't know how that slipped through. Alright, so let's solve the first one. It's actually already solved. The x is already by itself, but I'm going to show you what the graph would look like. So here we have a compound inequality. This is an and inequality. And if we graph this, all I'm concerned about when you graph these are the two main points, negative 6 and 2. Everything else really doesn't matter. All the interesting stuff happens around these 2 points. So I've got my x is greater than negative 6. If I read this way, x is greater than negative 6. So I'm going to take, it's not equal to, so I'm having an open circle, and I'm going to go this way. And then I have x is less than 2. So I'm going to make another line and go this way. And our solution set is going to be where these two overlap. So our solution set is right here in the middle between negative 6 and 2, which makes sense because if you look up here, my x is in between negative 6 and negative 2. So it only makes sense the solution set would say everything in between negative 6 and 2 is your answer. If I plug in 1, 1 is greater than negative 6 and 1 is less than 2, so that makes sense. So let's look at a different and inequality. This one actually requires a step to solve it, but it's just one step, so it's okay. Oh, go too far there. So we can solve this just like a regular equation. If I want to get this x by itself, I'm going to subtract 2 from it to get it by itself. But whatever I do to the middle, I have to do to the two outsides. So this is the only difference. You have to do it to 3 different parts. So just make sure, don't subtract from just the left one or just the right one. Make sure when you subtract from the middle or add from the middle or divide or multiply, whatever operation that is, make sure you do it to every side. So this becomes negative 3 is less than x is less than 2. And I can graph this one also. All I care about again is the negative 3 and the 2. You don't have to make a perfect number line. It's less than, it's not less than or equal to, so we're still dealing with open circles. And all and inequalities, where it's all just one time, one big thing where the x is in between the two numbers, you can go ahead and just make it just like that. There's your answer. Now this last one is an or inequality, so it's actually easier because it's just two equations. You just solve it just like two equations. So I'm going to add 8 to both sides. This is going to give me x is less than 6. That's one. And then also I'm still going to add 8 to both sides. And this is going to give me x is greater than 14. So here I have x less than 6 and x greater than 14. So when I graph this on the number line, it's going to look a little bit different. All I care about is the 6 and the 14. You don't have to make your little hash marks or whatever it is. This is telling me x is less than 6. Open circle, less than 6. And x is greater than 14. So again, open circle, greater than 14. So my solution set is like this. So basically, the numbers that satisfy this equation are all the numbers except the numbers between 6 and 14. That's the difference between and or. Your and or graphs will always look like this. These are and, these are or. They will always look like this. Okay, so your and graphs always include the middle. Your or graphs are always what's on the outside, not including the middle of those two critical points. And lastly, we're going to look at absolute value inequalities, and this is probably the one that is the most difficult, the one that usually trips students up the most. But if you can solve absolute value equations, then you can solve absolute value inequalities because they're the exact same thing. Just have to remember to set up two cases, your positive case and your negative case. Always two cases, positive and negative. So let's work through this example. All right, to save some time, I wrote this out already. So the positive case, that's what happens when the absolute value of 2x is positive. That's what happens whenever this value in here, this 2x, is a positive number. So it's going to be normal. 2x is greater than 8. That's all we care about. The negative version is what's going to happen when that 2x or whatever inside that absolute value sign is negative. So we write negative 2x is less than 8, or is greater than 8, sorry. And now we just solve these just like we would a normal equation. So I will divide by 2. This would give me x is greater than 4. And then over here, the first thing I would do is multiply both sides by -1. That way we can get rid of this negative. So that gives me 2x is less than -8. And then divide by 2 to give you x is less than -4. Okay, so there's one solution. If I want to graph this, I'm going to put my -4 and my 4. It says x is less than -4, so it goes that way. X is greater than 4, so it goes that way. So there's our solution set. So anytime you have a greater than inequality, it's always going to look like this. So you can kind of try and guess what our less than inequality is going to look like. Let's work this one out. Again, I set the positive version, nothing changes. And the negative version, I put in parentheses with the negative. And then let's go through and solve it like normal. So 6x is less than 24, x is less than 4, and I have 6x minus 3 is greater than -21 because I multiplied by that negative. So I'm just solving through here. 6x is greater than -18, x is greater than -3. So again, I graphed this just to save time, and you can see that a less than absolute value inequality looks like this. Got my critical points, and that's what it looks like. All right, and we're going to go over interval notation in class. So we can skip that. And if you want to get started on your work, you can. Here it is. If not, I'll see you tomorrow.